So we're in the practical part now of uh, the practical part of chapter 3. And let's go and see what's going on here. We'll share the screen first. Then we'll see examples of what we are going to say in this part. So we have on chapter 3, usually your logistic exam and the quizzes will include a practical part and theoretical part, theoretical and practical. So we will talk now about the practical parts of chapter 3. Here we have the task time. Task time, this is a law, is the available production time required by required outputs rates. Required by required outputs rates. Let's, as example, we have here 6 basic steps for the modeling: identifying the process, steps required, draw the precedence diagram, determine task time for the line, compute the theoretical minimum number, use a decision rule to assign the workstations, to have the number of workstations, evaluate the performance of the proposed line. Those are our 6 tips which we use for layout decision, for the layout decision. So this may be theoretical, but the most important thing is this model. Cycle time, maximum amount of time spent in any one of the workstations. Ideal time, IT is the ideal time, means the W actual, which is mean the actual number of workstations, actual numbers of workstations, uh, minus T, which is the plural or the sum of the whole time. So present ideal time will be the IT, which we get it from here. This is the IT divided by the WCT. Efficiency delay 100% minus P1, which is percent ideal time. So ED, efficient delay, equals 100% minus the what we get from this equation, 100% minus P1. Like if I tell you as example, a probability that you go is 30%, then what is the probability that you don't go to this place is 100% minus 30%, then it equals 70%. Let's see an example about this. Here are the workstations. So we have as example, look at this. I will go back and forth here so that you understand it. And actually, I won't get it to you like this. I might tell you to draw the flow of the stations, the diagram of the stations, and I will give you some calculus ready made. So you will apply the law in this case. Okay, task A, this is the start. The time of task A is 15 seconds. Let's go see here. This is task A. We put it in a square like this, task A, and we put down the 15 seconds. Okay, let's go for task B. Task B is 26 seconds. Look at this. Task B is 26 seconds. But if there is any operation before it, yes, text A is before it. So let's go here. I will come here and draw a square and put B and put the 26 seconds, B, 26 seconds. I will draw it, B and 26 seconds. But he said that there is something preceding, which is A. So I will make an arrow. I will draw an arrow from A to B. That arrow tell me that B is exceeded by A or A exceed B. Look at this. Here B, 26 seconds. The immediate, the one before it exactly, immediate exactly is A. So A is here before B. So I draw B 26 seconds. Then I put A 15 seconds. Okay. Then C is 15. C is 15 seconds. But C is also proceed the one before C, the previous one before C is A. Then here I will make a new square and write down C and the new square, a square, write down C, and C is 15 seconds. Then I will draw the C 15 seconds. Then what is the preceding one? What is the preceding one or the one previously? The one before it is A, the stage before it. As example, A is the wood. B is cutting the wood. C is cutting the wood into very small pieces. Or let's see, B is operation and C is another operation, but both of them are, A is per request for them. A is per request. Okay, so okay, so A is before B and A is before C. Let's say as example, you want to go to the second floor. So this is the first floor. You will make two stairwell. You will make stairwell B and you will make a stairwell C. But before you make B and C two stairwells, you have first to make stairwell A. Okay? Okay. And you will draw on each station. You will draw on each station like this 26, 25, 15, 15. You will draw the time on every station. Let's go to D. D is 32. Okay, I will draw a square and right inside it or beside it 32 seconds. The time of this stage D, time of stage D is 32 seconds. That's fine. Yeah, but before D, I have B and C. I have B and C. That means here is, I will draw the D and I will take arrow from the B and arrow from, because D is exceeded by B and C. D is exceeded by B and C. So I will draw D, then from there I will draw A, B, and C. Let me just explain it back. I will do it and explain it on the board. Okay, so this is now, I will do it right on the board also. When I finish it, I will draw it again on the board. Okay, let us now see this. After this, we made A and B and C and D. The stage E, like you see, is 25 seconds, but I have to watch out. Is there any phases before stage D? Okay, before stage E? Yes, stage D before E. So here I will make E 25 seconds, and I know that D is before E, so I will draw a line in between D and E. So when you read it, you will see it stage E 25 seconds and preceded by D. D was before it. D was before it. It was 32 seconds. Okay. Now, let's go to the stage F. Stage F is 15 seconds. Okay, let's see here. F, 15 seconds. What are you expecting? Without looking, I will see, without looking at the schedule, that it is preceded by or this stage E. So when I see here in the schedule, see F is preceded by stage E. That's fine. Okay, okay, that's fine. That's fine. It is so now F and G and H the same thing, preceded by E. F, G, H, preceded by E. But I will write the time of each one in front of it, like F15, um, F15, G18, H10. F, I will write 15 here, G18 here, and H10 here. Then stage I. Stage I will cost 22 seconds. But the stages which are before this are F and G and H. Like as example, if you are making shirt, then this is the sleeve, this is the back of the shirt, this is the front of the shirt. They all will go together to one place, which will stitch them all together, So this stage is called I. Stage I is 22 seconds, preceded by F and G and H. Look at this. Look at this. Stage I is preceded by F and G and H, and it is 22 seconds. Finally, we have the stage J. It is 24 seconds. Then I will draw a square and put J and write 24 seconds, and I will see from where it's coming. If there is anything before J, anything before J? Yes, I before J here, I before J. Then I will make a line from J to I to J. Let me do it on the board in front of you guys. Then we will see what does it mean. Like I will show it to you and okay. So I have first stage A 15 seconds, then I will draw like this A, and write 15 seconds. Okay. Then I have after this B 26 seconds, and before it is A. Then here is B, here is B. B stage is 26 seconds, 26 seconds, exceeded by stage A. Here is the exceed by stage A here. Okay, how about C? 15 second also. C is 15 second. This is C. It's 15 second, and it's exceeded by stage A. Exceeded by stage A. Then D, I have D, 32 seconds, but before it B and C. Then I have D here. D here. It's how many? How many D? 32 seconds. 32 seconds exceeded by B and C. Here we go. Exceeded by B and C. Then I have after this E 25 seconds exceeded by D. Then this is stage E. Stage E is 25 seconds. 25 seconds exceeded by stage D. Then it comes from stage D like this. Okay. Then after that I have stage F. 15 seconds. F. Here is F. 15 seconds. 15 seconds exceeded by the stage E is stage E. Okay, F. Let's move because F is 3. So we'll make it up here as example because we have from E 3 are coming. F, this is 15 seconds. We have also G 18 exceeded by E. We have G 18 exceeded by E. So E is here as well. E is here as well. Then we have also H, the stage H. H is, how much is H? 10. 10. And also exceeded by E. The stage H is exceeded by E. 10. Then I, 22. I, here is I, 22. And I is exceeded by 3, the 3 of them, by F and G and H. So I is 22, exceeded by F and G and H. Then finally, I have J. Finally, I have J. J. This is I. And this is J. And the stage J is 24 seconds. 24 seconds. And J is exceeded by I. Exceeded by I. And this is how I draw it. This is how I draw the stations and the stops and how I collect. So from the example here now, from this example now, which I showed you here on the board, I want you, now we can collect the total time. Yes, we can collect the total time. Let's go to the screen back share and see the total time. When I collect the total time, it will give me all this together, 15, 26 plus 15 plus 32 plus 25 plus 15. So all the time worked will be the total. When you make it with the calculator, it will be 202. Okay? Okay. Now, we'll move into another thing. Okay. Now we'll go to a new point in our work today. We made the stations, we made everything. We're done here, and this is the same one on the board behind you. Now we'll take, it's just equations and you apply in the equations. That's it. He gave me already that the total, the available production time is 28,800 seconds. The available, which where I know it, he will give it to me in the example. He will tell me in the example, like he said here as example, he will say that the available time for working is like this, blah, 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 is about like this. He will give you in the example 28,800. 28,800. I will give you this available production time. Okay. Required outputs rates 500 units per day. Because of what? He said $500, 500 units in 8 hours. This is in the example. Giving. It's giving. You just, what you will do is apply the law. That's it. You will substitute with the numbers which is given in the example with you on the law. So this will give you 800 divided by 500, it's 28,800 seconds divided by 500 units for 8 hours working. You will find it in the example. You will find it in the example here. He will tell you it's a 500 units in 8 hours working. Then this will come. The task time will be 57 when you divide it in each other, 57.6 seconds. Okay. Then the W minimum, we have it before, which will be the total time, 202 seconds. This is the 202 seconds, which we got, 202 seconds, divided by the number which you had from equation 1, which is 57.6, and that will give you 3.51. 3.51, this number, 3.51. But this number is representing the minimum of the station. W is working minimum stations, means how many stations like these stations I will have, how many stations like those stations, like these ones, how many. So I will say, because I'm dividing the work into stations, that means I will have 3.51 stations. You have to round it because there is no station. Station means a place for the production, a unit that the production stop in or go from. A station, you can say, you can resemble a station with a room or a place like attending place area. Okay, this is the station. As example here, F and G and H are three stations. Will wait till the stage or the phase E is done. Then E will give to F, and E will give to G, and E will give to H. Then, like I told you, let's say F is the sleeves of this shirt, G is the front of this shirt, H is the back of this shirt. Then I will stitch all of them together. So I will wait till F finish and G finish and H finish, and they will send it to them. Let's say 200 shirts. Then they will finish all the 200 shirts here. Okay. Then after that, I is the packing the shirt, put it in package. J is the package. J will wait till stage I is done. And this is the idea of the stations and the follow of the stations itself in the logistics system. Okay. So what you will do is the task time equals available production time. You will have with knowing that the available production time is 28.800 seconds. And the required output rate, while the required out, this all given in the example. This is all given in the example. So 500 units per day. Then what you will calculate, you will calculate the task time, you'll divide them by each other, time available production time by the required output. Then it will give you 57.6. This is the task time. Okay. If I have a task time of 57.6 and I have the total work will take 202 seconds, from where I knew I collected all this 15 seconds, 26 seconds, 15 seconds, plus 25 seconds, plus 15 seconds, plus 18 seconds, plus 10 seconds, plus 22 seconds, plus 24 seconds. Those all will come to and you can also get it from the sum here. It's the same. The same number. It's 202 when you collect it. So this is the only number which you will not have in the example. The other numbers, all you will have it. Okay. But watch out, because 500 units per day of work, like I told you. If I tell you they work for 8 hours and each hour they produce 30 units, then it will be 240 for the day. 30 by 8. Okay. So take care of this point. Others, everything will be clear for you. Okay. Then this will be here the task time, the waiting, the number of working stations will be 3.50. Nothing is called working. If I say 3 persons and 51.51 person, no, 3.51 means three persons and half a man, 2 legs and 2 hands. Same thing for the stations. 1 station or no station. So I rounded 3.51. I will make it 4 work stations, and that's it. You will have another examples, but we will have a very easy example for you for this idea. When you come to see now, what we will do, we will divide this work, this chat here, we will divide it into 4 slides. Number one, stage one, A and B and C. Stage B is D and E. Stage C or 3, F and G and H. And the final stage will be I and J. Again, the stage A and B and C. The stage D will be D and E. The stage 3 will be F and G and H. And stage 4 will be I and J. Okay. There is a connection, I mean, a meeting points. How I know them? Because of the meeting points of spreading points. This is separating between each stage and the other. A meeting point for the arrows to come, or separation points where the arrows goes. This you can know from that stage. So meeting points come here. This means the end of this stage. And separating arrows coming out, then this is means another stage. Okay. So here also meeting, this is the end of the stage, and after this there is arrows going this another stage. Okay. So each stage of this, we will calculate the points of it. We will have to calculate the points of it, like this, like here. As example, the workstation 1, A and B and C. 15 seconds, A and B and C. These points, A and B and C. Okay? All of them comes to 56 seconds. 15, oh, C, again. A and B and C. 15 and 26 plus 26 plus 15. Those will come to how much? 56 seconds. Same thing I will do for the stage 2, D and E. It will be 32 seconds plus 25 seconds. Look at this. Look at this. D and E. 32 seconds and 25 seconds, which come to 57 seconds. Then we'll go to workstation 3, which continue off G and F and H. Here we go. Here we go. F and G and H. They are 15 and 18 and 10 seconds, right? So all this will come to 43 seconds. When you collect them, 18 plus 15 plus 10, they are 43 seconds. Then stage 4, 22 seconds plus 24 seconds. This is the last thing, I and J. Those are 46 seconds. Now, we'll look for the longest one of them. The longest one of them. We have which one? 46, 43, 57, 56. I guess it's 57 because it's the largest number here is 57. The largest number for the stations is 57. That's fine. Great. Now I want to calculate something is called the ideal time. The ideal time. We will give it the symbols. We give the symbols like the symbols is the letters, like the initials. Take the initials. I for ideal, T for time, equals working stations, the number of the working stations, multiplied by CT actual, means the longest stage. The stage which take more seconds. We have 4 stages now. The longest one is 57 seconds. This one is the 57 seconds. Let us see where. This one, 50 seconds, which is station 2, because it takes D and E, take very long time, 32 seconds and 25 seconds. Those all come to 57 seconds. That's fine. That's very fine. Then I will multiply them. What I multiplied, 4. 4, here is the 4. 4 is the number of stations, because the result of the equations, the first equations, give me 3.51, which is 4. We rounded 4. This 4, I will take it, multiplied by the longest station, which is 57. Then, like here, 4 by 57 second minus what? The 202, which in the starting table minus the 202. The 202 seconds here of the starting table. This one, which is time in. For all the phases, for all this chart, the plural, all you add, 15 plus 26 plus 15 plus 32 plus 25 plus 15 plus 18 plus 10 plus 22 plus 24, it will give you 202. Okay, so what we did again, we have four stages, four stations. We got it from phase one, it's 3.51. Like here, when we calculated 3.51, we said there is nothing is called 3.51 stations. There must be four stations. Okay, we took the four stations to get the ideal time. We have now divided our work into four stops or four collections or four groups. Group working station A, and working station B, and working station C or 3, and working station 4. Okay, because we said it's around four stations. From the example here, it came 1, 2, 3, 4. And also, if you didn't know by this way, there is an experience one which said whenever there is arrows collecting or spreading, this is the end of a station and start of another station. Okay, so we have one station, this one, A and B and C. We have second station, D and E. We have third station, which is F and G and H. We have the fourth station, which is I and J. Okay, we will collect, we will add, make addition for every one of them. 15 plus 26 plus 15 will give me a number like this way. We did it here. 15 second, B 26, C 15, they are 56. Then same thing for station number 2, D and E together, then for number 3, then for number 4. Then I will take the largest number of the stations. I will take the largest number of them. The largest number of them is 57 of workstation 2 because the numbers are very huge. 57. Then for getting the ideal time, to get the ideal time, I will take the working stations actual, which is four stations. I will multiply by CT, which is the largest number of the four station, which is 57 seconds, minus the one which I collected of all the phases together. It will give me 26 seconds. Okay, then to get percentile idle time, the percentage, I don't need to say it because it's like you will divide the ideal time by the whole time of the, which we got here, 4 by 57, 22.8. So you will multiply 26 seconds by 228 and multiply by 100. This will give you 11.4. Okay, so if this is considered like deficiency, we consider it like deficiency, then the efficiency delay will be 100% minus. If I tell you you might study this night 11.4%, then how much you won't study the percentage? 100% minus 11.4% will give you the rest of it. Means 100% minus P1, which we get present idle time. So it will be, or 1 minus P1, 1 minus 11.4%, 100%, or 1 minus 11.4%. It will give you 88.6. If I get it to you, I will get it more easier because I will try to get the numbers for you in an easy way. Just remember the rounding. Remember here, the rounding is very important for you. Yeah. Just I want you to remember back. I want you back to remember. I want you to remember back that it's another example. Now we'll say again, we divided our work. Again, I will repeat this feedback. From the start, the available time 28 seconds, 28,800. This is given in the example, divided by 500 units per day, and this is also given by the example. It gave me 57.6 seconds for the task time. Okay. Okay. Then I will say the number of working station, W means working stations minimum, will be 202 seconds divided by this number. It will give me 3.51.4 workstations. Then I will have 4 workstations. Okay. My work will be divided into 4 workstations like I did in the board. This is the first A and B and C, D and E as the second workstation, F and G and H is the third, I and J is the fourth workstation. Then I will put each number of seconds in front of them. This is given in the example. Task A was 15 seconds, task B was 26 seconds, task C was 15 seconds. All will come to 56 seconds. Same thing which I did for working station A. 1 I will do for 2, I will do for 3, I will do for 4. Then I will take the largest number of them, which is now the first one 56, the second one 57, the third one 43, the fourth one is 46. The largest number of them is 57. Then this will be for me. Now look at here at the stations itself. This is a station A and B and C, D and E another station, F and G and H station 3, J, I and J station 4. I know it from 2 things. I know it from the result of phase 1, which I rounded and I made it 4 stations, which was 3.51. And I know it also because there is from the experience, the arrows, the direction of the arrows. If the arrows is splitting from a point and ending another point, that means it's an end of a stage. So here, this is an end of stage 1. This is the start of stage 2. And this is the end of splitting, start of the H3, and end of the splitting, start of phase 4 from here, and then is nothing after 4. Okay. Now, we said to get the ideal time means working stations, which working stations are 4 working stations after rounding them, multiplied by 57 seconds. Okay, 57 seconds minus 202. Okay, what is the 57? We said the 57, the largest one, the CT which we got, minus 202, it will give me 26 seconds. Then I will get the ideal time, the percent of the ideal time. It will be 26 seconds by the 228 seconds. Okay, so this will give me the percentage 11.4%. Okay. Okay. How about if I want the efficient delay is 100% minus P1. Also, I want you to notice that the W actual CT is the 228, which is this 4 multiplied by 57. What is the 57? Okay, is the largest station time, 57. Okay. Here we go. And this is the end of the practical part of chapter 3. Thank you.